Hello and welcome everybody to the webinar of today. The topic today is Zyxel switch portfolio, an overview. So what we are going to do, or basically I will tell you, is I will just show you a quite basic overview of the products we have, give you some short introduction about the naming rules so you can easier recognize what switch you're seeing as a model name. Then going over to the more or less complete portfolio we have in switching, and then some specific information about our PoE portfolio. Last but not least, I would like to introduce you to our new product range, which is specifically made for the IP surveillance market. So let's just jump in the basics of our switches. And basics actually means how do we name our switches? Actually, it's not big rocket science. You see, normally we have model names like saying GS 1920-24 HP or similar things. So you see the first two digits basically is ES, GS, XS, XGS, or MGS. ES is Ethernet switch, which means 100 Mbit. GS, and this is the most popular term we have, is gigabit switch. XS, X like 10, basically is 10G switch, so 10G only. XGS is 10G as uplink ports, and the rest, the traditional ports, are 1G. MGS is quite specific. This is metro gigabit switch. So this is specific, or these are specific products for our service providers. At the end, you normally see either nothing, which means it's a pure copper switch, or you see P or HP. P or HP always means it supports PoE. 90% or even higher percentage of our switches just show HP at the end, which means high power or PoE plus or 802.380, so supporting up to 30 watts. F means fiber, so if you, for instance, see something like -24F at the end, it means that it has 24 fiber ports. Fiber ports in a way that you have normally open SFP slots where you can plug in according SFP modules. If you don't see an F, it means it's a standard copper port. Then combo ports, what do we mean if we talk about combo ports? Combo ports means that these ports can run either as copper or as SFP module, so as or fiber port. So as soon as you plug in a SFP module, the copper port will be deactivated and it runs as a fiber port. Vice versa, if you have no SFP plugged in, you can use the copper port, but you cannot use that simultaneously. This is something you always need to know, especially when you're calculating the maximum number of available ports. If you have a combo port, you can use either copper or fiber, but not at the same time. Fiber ports, there are basically two differentiations right now. It's either SFP or SFP plus. SFP are the standard ones, so 1 gig, and SFP plus, but this is a quite common term, means that we are talking about 10G. SFP plus ports normally are backwards compatible to 1G, so you can also put in 1G modules into an SFP plus port. Of course, the other way around, it doesn't work. You cannot put an SFP plus port into an SFP slot. But again, this is quite generic terms, so nothing special. One thing to add, we do not have any coding or lock on our SFP modules. So in theory, you could use any brand on our switches. The port will not be blocked or deactivated. However, we always recommend to use our own SFPs, and this is just in terms of you experience any trouble connecting or getting a link, fiber link. It's always hard to support any third-party vendor because obviously we do not know what hardware he is using or what codes he is using. So even you can use any other brand, of course, we do not recommend that for mainly troubleshooting or support reasons. Okay, so that were the basics. Again, nothing complicated. So just to sum up the most popular things, GS means gigabit switch, XGS means gigabit with 10G uplinks, and XS means 10G only. And at the end, you found either nothing, which means a standard normal gigabit switch, HP, the most common one, and this means PoE support up to 30 watts per port. And last but not least, from time to time, you see an F at the end, which means it's predominantly a fiber switch. That was it. Coming to the portfolio, and again, it will be a very short overview, so also here nothing complicated, not into the deepest feature sets. So just to let you know, these are the models we have. This is the positioning, this is the differentiation, but mainly on the hardware side. So it starts with GS 1200. As you remember, GS means gigabit. 1200 series is entry-level Soho Web Managed, so it has a very basic web GUI which you can configure and basic settings like some VLAN and QoS, but that's mostly it. We have 4 models, 2 5-port, 2 8-port, one with PoE, one without PoE. All of them are fanless, so they are ideal for actually connecting 1, 2, 3 access points in a small environment, or maybe some VoIP phones or similar things, also an IP camera. But again, mainly targeting either end users or small offices or home offices. Next series we have is the GS 1900s. There we are already moving to the small and medium business sector. Here we have various models starting from 8 ports with and without PoE, and then ending with 48 ports as PoE version. You just need to remember that the 48 HP only supports 24 port with PoE, and the other 24 port are just pure copper ports. The PoE budget starts from 60 watts on the small 8 ports and goes up to 170 watts to the 24 and the 48 port version. 170 watts is normally enough for quite a lot of devices. The average power draw, depending on what you use, access point, VoIP phone, or even a camera, is normally not much more than 10 watts. And then you basically can calculate that you, in theory, could connect up to probably 20 something devices, which is already quite a lot. If you especially go to a wireless application, you have 20 access points, this already covers quite a large area. 8-port PoE, and the 10-port PoE. In this case, 10-port means 8 copper plus 2 fiber uplink ports. Both or all 3 are without a fan, so no noise. You can put it basically anywhere you want, even on your desk, and you won't hear them. 24-port and 48-port do have fans. In terms of features, they are quite standard SMB features, so supporting VLAN, QoS, rapid spanning tree, link aggregation, pretty much everything you need in a small SMB environment. Getting to the next model, this is the XS 1920. It's quite a niche one. XS, as you remember before, means gigabit 10G only. This model has 8 10G ports and 2 copper-based, and 2 dual personality ports or combo ports, so either copper or fiber. This is mainly to connect servers and uplink them to any other 10G switches to have the full bandwidth. So far, there's only one model in this space, but we will add some new series, which is the XS 1930s. They will have multi-gig BT 60 watt PoE support, also 10G copper based, of course, and some fiber ports. So we will enhance the series, and all know that the demand on bandwidth is increasing, and you have more and more devices who support 10G uplinks or downlinks, depending on where you are looking from. So this series will be enhanced, and the XS 1920 is, again, so far just more or less a niche product. Going to the next page, you see actually the products we are currently selling the most, and this is the GS 1920 series right now as a V2 version, which we just introduced end of last year. This is our best-selling series. Also here, it starts with 8 ports and goes up to 48 ports. Main difference to the 1900 series is, or actually there are several. First of all, it's supporting Nebula Flex. Nebula Flex means you can run this switch either as a standard normal web managed standalone switch, or you can change it to cloud managed with our Nebula solution. And this is without any cost. You can just shift around. Well, you shouldn't, of course, shift around all the time, but you can choose if you want to manage it as a cloud switch, so multiple switches, multiple locations, or you just say, okay, I'm fine with the standard standalone configuration. Second difference is the PoE budget, especially if you compare the 8-port 1920 to the 1900s. It has actually double the PoE budget, 130 watts compared to 60 watts or 70 watts with the 1900s. If you go to the 24 and the 48 port, it's pretty much the same story there. We are talking about 375 watts on the 1920s versus the 170 watts on the 1900s. Also on the A48 ports, you have all 48 ports supporting PoE. In terms of features, of course, there is also a little more because this series is more for project business and bigger SMB networks. In terms of hardware, there's also a little differentiation. We have a hardware reset button or actually restore button. You can choose which configuration you set as the default configuration, and if something goes wrong, the switch cannot be accessed anymore, you can use the hardware button and reset it to your last saved configuration, which we call last good configuration. Quite convenient, quite important in web managed switches, especially as you do not have any other option to configure or reset it besides maybe sending it to the support and they can basically do it, but it's not that easy. In addition, they have an LED indication for the PoE model. So on the front panel, you will see the power consumption, which are shown by some LED lights. So there is some levels like up to 20% to 60% to 80%. You have different colors, or the lights will go up. And on the models, we have 5 lights. So if it's in the middle somewhere, everything is okay. If the color is red, or you see that the lights are going up to the highest level, then it shows you that you have some at least little issues with the total PoE budget, which means you might need to consider adding another switch. So this is the main difference to the 1900 series. Again, 1920 is rather for project business, vertical business, and for bigger SMB environments. Next one is the XGS 1930 series. Pretty much the same story like we have on the 1920s, same power budget, same port counts, besides the fact that these switches have 10G uplinks. So this is the most important thing. All the rest is similar to 1920s. Also here supporting hybrid mode, meaning Nebula Flex Cloud or standalone management. Features are pretty much the same. Also the LED indications, also the reset button, same power budget. So it's mainly about the 10G uplinks. On the very right side, you see the NSW series. NSW series is purely cloud managed, so they cannot run as standalone switches. You always need to register and configure them with the cloud, our Nebula cloud platform. For the models, we have 10 ports, PoE, non-PoE, 24 ports, and also 24 port gigabit with 10G uplinks. What we're missing so far is 48 port. On the other hand, of course, we have the XGS 1930s, which are capable of running under Nebula. So these are also products we mostly use in project special applications where the requirement is to have only cloud management with specific features, professional features. So there is a professional license included, which is advanced to what we have in the Nebula Flex free license. Of course, you can buy the professional license for the Nebula Flex as well. But the NSW series already comes with a 1-year professional pack. So again, this is mainly for bigger installations for projects. Going over to the next page, we are already in our managed portfolio. Again, the difference between web managed and fully managed is that the fully managed switches, besides of course having some more features depending on the series, have a command line interface. So besides the standard management over the web GUI, you can also use the command line interface for managing. I will go quite quickly through it. The story is also quite similar to what we had before in the web managed in terms of models. We have the GS2210s, which are pure gigabit. Also here 375 watts max PoE budget, different port counts, different feature sets. That's layer 2 standard, so the most popular, most common thing. Then we have the XGS2210s, which is same like the GS2210s In addition, they do have the 4 10G uplinks. Last but not least on that page, you have XGS 3700 series, also here gigabit switch with 10G uplinks. And the main difference here is, besides they already support some layer 3 features, is that these switches have an option for dual power supplies. So you can either use it for redundancy, or you can increase the power budget up to 1000 watts by using a second PoE power supply. So this is more or less a switch for bigger SMB, SME projects where high redundancy is required, like IP surveillance, any other kind of security where you need to reduce your downtimes. Then these are the highest models we basically have. XS3700 is similar to the XGS 3700, with the difference that it has, of course, only 10G like the XS says. But this will be replaced now slowly by the XS 3800. This is a quite flexible product. As you can see, it has 8 combo ports, so either copper or fiber 10G. It has 16 10G SFP slots for fiber connection, and in addition it has 4 multi-gig ports. Multi-gig means it supports 1G, 2.5G, 5G and 10G on the same port. Last but not least, our layer 3 products, XGS 4600 series, so it supports all the layer 3 features you normally need, including OSPF, including RIP, including VLAN stacking. Standard stacking is also supported, by the way. This is normally used as a core central switch or any kind of bigger installations where you have layer 3 networks. We have 3 models here. One is 28 gigabit ports plus 4 10G. The other one is 48 plus gigabit plus 4 10G, but only fiber, as you see in the naming, 25F. And you also have the 32F, which basically means it has 28 fiber slots, gigabit plus 4 10G. So these are all our switches we have as standard classical SMB products. The portfolio is quite standard. Of course, we have some unique features, especially the hybrid mode on the GS 1920s and XGS 1930s, which you will normally not find in this segment, especially not in this price segment. Also, the power budgets we have on the 1920s and XGS 1930s is very high compared to what you see in the competition, and it's also sufficient for even bigger networks. So coming to the little special part, but also quite quickly through it, the PoE. PoE is our most successful space we're selling in. So power over an Ethernet, this is where we are selling most of our products. Actually 60% or even higher is going, our switch sales is with PoE. We have very good feature sets here. We have very good portfolio. So I just want to give you a short introduction what we have. In general, I mean, we have different classes of PoE. So just to let you know that the old one was the AF standard up to 15 watts. The current and most popular one is the AT standard, or also called PoE Plus, which is supporting 30 watts. And this is back to the first slide. I showed you everything which we name HP is supporting exactly this AT standard, so 30 watts per port. Last but not least, and this is also quite new and not so popular so far, probably it will be with new devices coming up, is the BT standard, and this supports up to 60 watts. So some people call it also PoE plus plus or ultra PoE. This is all the same, but the official standard is 802.3 BT, which means 60 watts per port. Again, what you normally find with our switches is HP, which means we support up to 30 watts, and this is also backwards compatible to the AF standard with the 14.4 watts. One thing we do, and this is also quite special in this segment, we do have 2 modes. One is the classification mode and one is the consumption mode. Classification mode basically means you connect a device, it has an AT standard or supports AT standard, which means the switch will reserve 30 watts on this port. Regardless if this device maybe just only needs 5 or 6 or something like that. It will just negotiate, well, what standard are we talking about, and then it will reserve this wattage on the port. In addition to that, we do have the consumption mode, and consumption mode is a little more sophisticated, a little more clever, because this consumption mode will negotiate what's your real power consumption. So not just spreading out by default the maximum power which might be needed by standard, but really negotiating, okay, this device only needs 10 watts, so I will not reserve 30 watts, I will just reserve 10 watts on this port and send 10 watts on this port, which in the end is beneficial to you because it saves you the amount of switches you need. It's just simple calculation. Without this consumption mode, you have, let's say, 170 watts on a 1900 switch. So, and the standard of the connected devices is 80, which means 30 watts. You could connect maximum 5 devices. 5 times 30 is 150, and you have 170 watts power budget, which is quite annoying if you have an access point which only draws 7 watts, for instance. So you can shift to consumption mode, and then you have just a power reservation of 7 watts per port. And you could, in theory, connect up to 25 devices. And this is something you should always do. People might ask, why do we have the classification mode then if this is more or less the bad thing? No, it's not really bad, especially when you have old products or products which are not really following the standard or are not able to negotiate the power consumption. Then you need to leave the port on classification mode, because then you can ensure that these devices are powered up. So we had these cases where people turned it on consumption mode and the negotiation didn't went correctly, because the connected power device, access point or camera or things like that, did not support it. So they need to have the classification mode, and they need to reserve the full wattage on the port and not really negotiating the real demand. This is why we have 2 modes. Consumption mode is activated by default. If you experience any issues, you can go back to classification mode and see if the devices boot up. Going to the portfolio, but it's quite or a little repeating what we have. It's mainly about, of course, the way of managing and the power budget. Again, you need to differentiate between the standard, which tells you how much power you get per port, and then the wattage you see on the switch, and this is the total power the switch can provide. So it starts with the 1200 series, as you can see, 70 watts, then it goes to the 1900 8 ports with 60 and 77 watts. And then, as already mentioned before, it goes to the 1900 series or the Indonesian RGS series, 130 watts with the 8 ports, 170, and goes up to 1000 watts with a dual power supply on the XGS 3700. Of course, you still have the differentiation in the feature sets, so you need to more or less define what features you exactly need, software features, but the main thing you need to consider on PoE switches is, of course, which power PoE standard do I need? Mostly it's the AT standard with 30 watts. And what is my total power consumption? And this is basically the number of devices connected times the wattage they need. So next slide, and this is the last, let's say, segment we have here, is our new IP surveillance series. So these are products we just launched more or less right now, and these are tailor-made for specific vertical, and as you probably can think of, this vertical is IP surveillance. Getting more and more popular. Also, there is a change now from the old analog cameras to IP-based cameras, and pretty much every or each of these cameras is powered by PoE. Of course, as you've seen, we have a lot of experience in PoE. We have a lot of models in PoE. On the other hand, what we learned from our customers is that, especially in this IP surveillance market, there are some specific requirements or demands, which we try to fulfill with this new series. we have several models here. It starts actually with unmanaged. Unmanaged because in this segment, a lot of people are okay with just having a switch transmitting data and powering the devices. So we have three models, 10 HP and going over with 10 ports or 8+2, going over to 26 ports, so 24+2 basically. The main difference also here is the higher power budget. So also here the 8 port starts already with 130 watts. Going to 117 on the 18 port, and then last but not least 270 watts on the 26 port. Both of course, or the free, as the naming says, HP support the 30 watts standard. So this in terms of port count and PoE budget. We have additional products which are managed. One model more, it already starts with a 6 port. This 6 port, as you can see at the bottom, already supports the BT standard, so up to 60 watts power on one port. Then we go over to a 8+4 switch in terms of port counts. Then we go to 16+2, and last but not least, also here the more or less standard and common 24 port version. What's now the big difference besides the color you see? They are not black, carbon black, as you normally see our switches. They are already gray, which is a differentiation in the market, in the segment. First of all, they support extended range. Extended range means you can run up to 250 meters over the copper connection, and also providing then the PoE up to 250 meters. The standard, the Ethernet standard says the maximum cable length should be 100 meter. Everything above for more than 100 meters is more or less luck. While here we can ensure that it goes up to 250 meters, but, and this is the only but, it runs on 10 megabit. This is something we need to do to ensure the quality of the data and to ensure sufficient power. However, 10 Mbit for IP surveillance is most of the times more than enough, depending on the compression rates you are using. Even HD bits, full HD bits do not require more than, let's say, 7 to 8 megabit per second. So 10 MB is pretty much enough for 99% of the current cameras. Of course, probably not if you're running ultra HD cameras with no or not that good compression, then it might be a little difficult. But again, most of the cameras, or pretty much all of the cameras right now in the market would be fine with this 10 MB. So extended range is one feature which is different. Coming to the next one. Continuous PoE. Continuous PoE means the switch will provide PoE even if it's rebooting, which is different to all the other switches. Normally, if the switch is rebooting, it also turns off the power on the PoE ports. The big benefit here is actually that you reduce the booting time of the cameras. You could also say you keep recording. On the other hand, if it's a pure network camera, of course, the switch is not transmitting any data if he's rebooting. So there is no benefit as long as you do not have cameras which do have an internal SD card to record the videos as well as a backup or as a main thing. Then of course you still have the recording, but even if they do not have internal storage for recording videos, you have a big benefit of not need to reboot the cameras after the switch is on again. Normally the switch reboots in, let's say, 2-3 minutes. So what would happen without the continuous PoE? Then you start to reboot the cameras step by step, or port block by port block, which can take up to maybe 10 minutes or something like that to have all the cameras up and running again. In this case, you save this 10 minutes completely, because when the switch is booted and the camera stayed on, you have immediate transmission of the video signals again. So this helps you significantly to reduce the downtimes. Of course, there are various reasons for a switch reboot. You can do a configuration change which needs to have a reboot. You can do a firmware update, or maybe it's just something, some other failure you have, which happens unfortunately from time to time as well. So again, main thing is here you reduce your downtime by keeping the cameras alive even if the switch is down. Camera status, also here, this is a feature where you can see on the web GUI of the switch the camera status, if it's alive or not. You see the model name, you see the IP address. If it's supported by LLDP, you can also cycle, which means power on, power off the device from the switch GUI, or you can reset it to the default setting if it's needed, all through the switch GUI in a good overview, and not need to type in the IP address of each camera manually. Quite similar to that, but way more convenient, is the feature we have last but not least, and this is the auto camera recovery. What we found that the biggest struggle the IP camera installators have is that if something happens, they do not have a video signal on their NVR. Best thing they can do is they need to go on site to the camera, check the status, what's going on. Worst case, plug in the PoE cable and put it in again so the camera reboots, which can be quite annoying, can be time consuming, costly, depending where it is. So we have a feature where the switch is monitoring the status of the camera. You can choose either LLDP or ping. So ping is the most secure thing because every IP camera should have a ping. What the switch does then, he is pinging or polling the camera in a predefined time range. So you see there polling interval seconds. You can define how often he does it. You can define or what time range he does it. You can define how often he does it, and you can say what's happening if you did it 3 times and the camera does not respond. Then you have 2 options. First one is alarm, so we'll just send an alarm message to a syslog server. The second one, and this is the more important one, reboot an alarm. So you get an alarm on the syslog server, you and the switch will reboot the camera. To avoid any loops, we also have a setting which is how long will the switch wait to start polling the switch, the camera again. In this case, you see 600 seconds. So of course, we do not want to keep the switch polling the camera every 20 seconds when the camera reboot, even if it's successful, needs maybe 3 minutes or something like that. Then it will be an endless loop. We can also say how often he will do that. And we can also, and this is the last column, specify how long the switch will wait until he powers up the camera again to after he shut it down. This is a standard procedure to remove any electricity whatsoever from the capacitors. So it's really completely discharged, and you can be secure there's not still any bad thing in the camera running. So in this case, the last column says wait 10 seconds after you shut down the camera and then turn it on again. So this is a feature very well appreciated by most of the people we talked and who are installing cameras, and this is easing a lot of their pains. So last but not least, what we have on the 1350 series is the advanced search and ESD protection. Of course, here it's also quite important depending where the cameras are, mostly or not mostly, but there are occasions where they are somewhere outdoor, parking lots, any kind of other outdoor areas which they need to monitor. And of course, there is a chance that the lightning flashes in, and therefore also our switches have 4 times and higher search protection than standard switches and 2 times higher ESD protection, which of course also ensures the lifetime of the switches. So that was it for the presentation. Again, nothing too complicated, just to give you a rough overview. Of course, if you have any other questions, you can always contact our support teams, or you can contact your local sales guys. And they will help you out if you have any questions. So thanks for your time. Thanks for listening to this webinar, and I hope to talk to you soon. Bye-bye.